Good afternoon, everybody. Welcome to my channel, Data-Driven Decisions. If there's one skill that I know I'm very good at, and that would, for you to learn from me, it would be SQL. I know it by heart. I have been using it for pretty much every project, for every job, for the past 12 years. Um, you know, um, I pretty much do everything in SQL. It's really lately it's you use Python for ETL. Data always comes from a source place, and you want to drop it in the database, and so you use Python or ETL tools to do that. And then goal number one is to land all the data, just not touched, not manipulated, nothing, but just land the data in the same place where it can all be worked with together. So in the database. BigQuery is what I know the best. That's just because of the company I've been working for. We use GCP, and I like BigQuery quite a lot. I've gotten used to it. I'm a rock and roller in that, and I can rock and roll in any environment. As a matter of fact, every project I get put on, and it's always a nice, distinguished company. Very prestigious companies are asking for our help. We have a very prestigious, ego, I guess, and the tech stack is always different, but no matter what it is, you're always going to find the ability to use Python and SQL. And it allows you to work in any new tool and rock it and get away with not understanding the full environment in and out. For instance, I just did a project with Microsoft Fabric, and that's really the hottest data and analytics ecosystem put together by Microsoft, where it really just streamlines all data projects, and it brings together all of the tools, such as Data Factory, and then Synapse, and uh, uh, the database. Um, it was, for me, I got by, and uh, I think I did it exactly the way Fabric was intended, but I front loaded all processing in the database, or what we had as our database, which was it was in the Power BI realm. It was just in a simple notebook, and I just wrote a script, a long script, and uh, some of it had Python, some of it had SQL, and it just switched between, and it was just a simple script. I mean, um, I got by, I rocked it because of SQL. SQL's constant, and that's really, you can put all the work in SQL, and that's what I recommend you do on a data and analytics project, because migration will be so easy if you do as little as possible in the BI tool. If you choose not to even touch the semantic model and do data transformation and data merging, in the Power Query or whatever the semantic model is, if you just avoid that and do all processing in the database in SQL, it's a beautiful thing. It's a screaming fast dashboard. Um, it's 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 every table is not uh, upstream or downstream from any other table. Every table is just a raw copy of what the data is from the database, when it comes to if you do a lot of data merging and data unioning, if you're combining tables inside of Power Query, it's a mess. The order, is so important. Like you got to deal with, do these steps before the merge, do after the merge. And now you don't have tables that are all of, level 0 where they're all not dependent on anybody. They're all just raw copies. None of them are built off of each other. And if a table is built off another table, that takes time, that takes processing, that takes user waiting for the dashboard to render, because all that needs to be done. Now, good news is Power Query is not done on the fly. Anything in Power Query is an ETL. It's a script. It runs. It just finishes with the ending tables that are in Power BI for dashboarding. But you just with Microsoft Fabric, there is no Power Query. You have to front load all processing. It was, you have to build a notebook, and you in the notebook you have to define all the final tables that Power BI is going to point to. And then step 2 is building a semantic model. And that's another layer. It's another file that you build inside of Microsoft Fabric that combines the tables, that defines the measures, defines the sort orders, defines the formats, just defines the final data and the data model. And then after that, you start dashboarding in Power BI, and you don't have the option for import anymore. It's direct query. So it's always going off of off of the database. I wonder if the semantic model, stores the data, if it's a script or if it's something done on the fly. I don't imagine so, but we didn't have the option to import the data inside of Power BI, which is always what I like to do, because the VertiPack engine, whatever DAX and Power BI is built off of, it transforms data very quickly, and it stores it very efficiently. And I always want to suck that data into Power BI and let it handle it, and wait that time. Just give the daily or hourly ETL times where the data refreshes, and the time that finishes, then just replace the final dashboard. So yeah, SQL is really what I know, and let me show you my my personal finance SQL. I mean, it's basically what I do for every single job. So I'm a senior business intelligence engineer. I work for a really, really nice consulting company. We are really bright. I'm not really the brightest. I'm not. I'm probably lower echelon, but I try to make it up in other areas. You know, very much a team player, very helpful to newbies. We always bring on new college grads every summer, and I always help them out. But moral of the story is SQL is always what makes me succeed in my job. SQL's everywhere. Every project has a database. If you're not working with a database, what are you smoking? There's going to be a database, and every database is SQL. So it's the same language, different dialects, but you just Google search functions and stuff. But you always end up, for me, in my career, front loading the processing. That's probably rule number one that defines me in who I am and what I do differently from most people. If I have the option, I'm going to front load all processing in the database. And you know, fail not or just not try not to do anything in Power Query. And that's that, leave Power Query alone. Just like in Fabric where you can't even use it. It's kind of I think this front loading the processing philosophy is winning, where you do everything in SQL. Truthfully, you can do everything in Python. If you're a whiz in Python, um, I'm sure there's people like that. As good as I am at SQL, they're as good at Python, and I tip my cap to them, and that's awesome. For me, the two languages that I became absolutely fluent in were SAS and SQL. And I haven't used SAS in 5 years, and I don't intend to ever use it. Personally, Python, I'm not fluent. Everything I do is basically from Copilot and from Google searches. I'm not, what I can do in SAS or SQL in both those languages is just write it right on the fly, write code on the fly, because I know all the commands by heart. And really that's what you want, when you get that with a language, you become a unicorn. You solve problems so quickly, and I think we all each have that niche, as programmers. We all have our first language, and my first language is SAS now, or not SAS, SQL. SQL is what I use for every project, and Python is certainly my secondary language. And I really get excited working in Python. Honestly, it just, as a business intelligence engineer, it just isn't used nearly as much as SQL. I know there's certainly a lot of people who can do everything in Python, and I tip my cap to them, and I want to start doing that too, just to say I can. I know how to do it. I'm certainly going to continue working in a database, but you can always write pass-through code in Python that sends code to whatever database you need to, and I can just totally do that. But yeah, SQL is my first language. When I say front load all the processing, it means that you take the source data and you turn it into the final data, and intend not to use Power Query, intend not to create any calculated columns in Power BI. Only create measures. Um, get to the absolute final things in the database. And sometimes some visuals need the data transformed in different ways for it really to sing as a visual. Much like a lot of the plots that I use. These dashboards have data all coming from different levels, from different ways. The data is shaped differently, and it allows different visuals to come out. So with SQL, this is the table of contents, and this is just pretty much every table in the exact order. And order really matters because you use tables that come before in your most current script. And honestly, when you add things to this, you can always just add to the bottom if it's a new table, and now everything has the option to be dependent on it. But if you sneak something in between, you just got to understand that you don't have access to tables that come in the future of the script. You can't use those. So, it all is a matter of what tables you need to use to build your project. That's kind of where you insert it. But, you can always be safe and just start at the bottom and let every table be your source. But, in general, it's just an execution of tables is what a SQL script is. And this is the execution of this. This is like a 20,000 line code. Uh, but at the end, it's just a chain of tables being made. And you can see like intermediate tables, you know, have the same name, just with a different number on it, and that makes adding more easier. You know, just give them numbers; they don't have to have names. You know, I give them the description over here to the right. So there's intermediate tables too, and I just do the easy old-fashioned way of just putting a number at the end, and I keep them. You know, and that's cool. Um, uh, yeah, I mean, as far as like teaching SQL, let me try to find a simple script. I know where one will be. Credit card stats. Let's find this. All right. So this is a simple SQL script. I think this is the best way to train. Um, what is this saying? It's saying select one dimension, account name, and sum up this field called amount and name it amount. And from the table that you're going to collect this from is this table right here. And this is always two parts, the database and the table name. And then comes next is the filters, and that always starts with the where clause. And here I have two filters, one where category equals credit card payment, and then and date between these two dates. And since this is, I'm aggregating, you know, you see this sum, that's an aggregation. You're always going to need a group by, and it's just the count of the dimensions. So in this case, just one. If there were two dimensions, it would go 1, 2, but it's just one. And then this comes post everything, and then it just orders the table. So this first gets executed, and then this happens, order by. So this produces a table, and what is it? It's sum of amount by account name, and it's sorted descendingly by amount. So it definitely showing American Express was most used. Yep, go figure. Um, and that's really the basis of a query. That's a simple query. So it's you know, every query that you see starts with a select statement, and then it's fields, and then it's from a root table, and there's joining. Joining is a huge part of SQL, and you should always just do left joins, pretty much. Um, but that's really a general query right here. You know, you got to learn it by heart. It's so simple, but with this, you can do so much. Um, you know, there's you know, where is filters pre-query, and then there's post-query with having. You can filter on a metric where amount is greater than 4,000. All right, so this should give me a smaller table and only shows 2 rows now where the amount is greater than 1,000. So that's another piece of SQL. Um, you know, you can always give tables aliases. If you're going to start joining tables, then you got to start doing aliases. I recommend A and B, C, D, E, F, G. That's it. And you know, it's always a left join, because it's always a fact table, which is from in the from clause. Your biggest table, it always comes first, and then think of everything else as like a dim table that just gets left joined to it. Doesn't affect the granularity of this table. You want the granularity of the output table to be the same granularity of this from table. You don't want any join to affect the granularity. If you are, you're probably doing something wrong. And I see that so common. You know, inner joins are bad because it has a filter in it. If it's not in the left table, it filters out, or in the right table. But you know, I can find, I can add the date table here. So let's add that date table. Give it B, and on A dot equals B dot, and how do we join these? Uh, Finances mint transaction. Really is a matter of figuring out what's in these tables. Select all from. Let's just check out the fields in this table. Let's do the same for the date table. Copy, paste, copy, paste, copy, paste. That's all you do. All right, date, I'm thinking, and then mint transaction, does it have date? So date, A dot date equals B dot date. And let's add year. So we're adding a field from the second table to this query. Now it's got 2 fields to group by and 2 fields to order by, but we're going to order by 3 des, the metric. So there's the name date is ambiguous. No, we got to do that. That's that. So now the query got a little more advanced, but it didn't really show that because of that date filter. But now that I just simply commented it out, the way you structure the code allows you to comment it out. If I need to comment this out, this is what I do. Where 1 equals 1, and so now I can comment out every filter, and 1 equals 1 is always true. That just does nothing. You can always just have where 1 equals 1, and then you add your first like that. Oh crap! I hit the run everything button. Let me cancel that. This whole script takes about 10 minutes to run. At the end, I kind of capture snapshots of tables, and it just kind of just accumulates and accumulates, and those tables are getting big. But I like now I got some big data. I got some 12 million row tables now, so it's kind of like a big data project, this personal finance thing I've done. Yeah, this table now is just segmented by year now too. That's kind of how you add a new dimension. And a key concept to SQL is dimensional modeling. You're always trying to end in a dashboard to visualize your data using reports and stuff. Dimensional modeling is all about dim tables and fact tables. And you honestly can think of any table as one of those two. And when you join tables, you always start with the fact tables, and then you just join in the dim tables. When you build data models in Power BI, there's nothing wrong with having many fact tables and in dim tables. Like, you see how many tables are connected to the month table. Pretty much every table. There's so many fact tables that need the month table, but the beauty is I can just source from the month table, and it will factor everything in a dashboard. That's what's allowing me to build reports that have data from different all across this data model. Just the fact that almost everything is connected to month table. I can use date to filter all dashboards, and that's the most common key of all these joins. So yeah, that's the basic of a query. Dimensional modeling. So like I said, tables are either fact tables or dim tables. Inside of a fact table or inside any table, there's dimensions and metrics. You don't really get metrics in dim tables. You only get facts, attribute values, dim fields. But you can get numbers, such as years and stuff, date of birth. But the fact table is keys. Everything's got a key. You got to know the primary key of every table. What makes every table unique? That always depends on how you join the table. You always try to join on the left joins table's unique primary key, so that way you're not changing the granularity of the fact table. So date table is unique by date. That's why you join on it. You always join on that unique key of the B table, the table you're joining in. You never want to affect the granularity of this table. Always do left joins. You never want to do inner joins, because an inner join is a hidden filter of saying if you're not in this table, then it's going to get filtered out. And you probably don't want that. You never want to really change anything with the fact table. You don't want to change any rows. Only if you're explicitly told to delete rows, you will filter them out, but you really never want to get rid of rows from the fact table. So always be careful with inner joins. Never do a right join. You always start with your fact table. Never use a right join. The one I love to do are cross joins. Sometimes you need to build a shell table that has every possible combination of attribute values, and that way you just first grab the unique list from two tables or from two fields, and you cross join them together to get every unique combination. That's probably the second most common join I do. Or I do a simple join on every row. Just like the B table is just one row, and I do on 1 = 1 so that it joins every row. That's very common, but for the most part, it's left joins. And all this is just an ordered script of commands. Since I wrote it, I know it by heart. I know where everything is. It's long. There's no really macros in this code, which is a shame. With a Python, with SAS, you can turn all this into macros and really condense your code and build really smart code. But when you're working with simple database SQL, you don't have that luxury. So sometimes you really have to go the long way and do things explicit, such as kind of things like this. These unions. This is making a columnar table. Anyway, if, like I said in the beginning, if you want to learn something from me, I've been showing you a lot of things, investing advice. I'm not an investment broker. I don't know. I just read books on investing. I have personal finance advice. I'm not an expert. I'm showing you my personal finances, and they're not great. I'm not the best. But what I do is business intelligence, and most notably is SQL. I write SQL, and that's what I shine at. That's what if you want to learn something from me, that's probably what you ought to learn. That's what I'm really fluent with. So thank you for listening, and please leave a comment if you're like this video and you're inspired to learn SQL. Alrighty, thank you.